Good afternoon, class. I'm Karthik, Assistant Professor, Mechanical Engineering Department from SNS College of Technology. As I already said, this tungsten inert gas welding, we have said it is a type of it's a process, helps to join two metals with or without filler metal, with or without pressure. But here we are using the non-consumable or not melted, non-melting tungsten electrode, right? So when we come to the GTAW processor, the arc develop intensive heat and it is approximately 6,000 degrees Celsius. So that which melts the surface of the base metal to form a molten pool. And here the filler metal is required to make the weld, and it is added manually like brazing. And for thicker materials, an externally fed or cold filler wire is generally used. The filler metal is not added when thin materials or edge joints and flat joints are welded. So this is known as autogeneous welding. Means that if you are using filler rod, additional filler rod for the welding, then then it's a normal welding process. If the filler rod is not used, we are making the base metal to melt and join together. It is known as autogeneous welding. Here the filler metal is not transferred across the arc, but it is melted by it. Here at the previous type of welding, the rod is melted and it is transferred with the help of the arc. But here it is no way. Here the filler metal is not transferred across the arc, but it is melted. The arc area is protected from the atmosphere by the inert gas, which flows from the nozzle of the torch. So here the torch contributes only heat to the workpiece. The melt means that this heat helps to melt the filler metal and get coated, right? So the main advantage is that when compared to any other welding process, this TIG welding or GTAW produces the excellent quality of welding and has a high precision rate. Moreover, welding more kinds of metals and alloys. It can be used for stainless steel, nickel alloys, titanium, aluminum, copper, brass. As compared to the shielded metal arc welding, it is mainly used for ferrous metals. But this tungsten inert gas welding can be used even for non-metals, and we can say it is more preferable. It is more preferable in both filler and both ferrous and non-ferrous alloys. So it also can be welded dissimilar metals to each other, like copper to brass or stainless steel to mild steel, and it's also suitable for all positions. We have many positions of welding and it is suitable for all positions. The main important point is it's a concentrated arc, means that it has a pinpoint control of heat input to the workpiece. When we compare to SMAW, we have some spatters. That means the workpieces means that the electrode which is melted can spill out. But here there is no way. It is here it is a concentrated arc like a sharp laser. So it will so that the metal deposition is higher and it has a very concentrated, accurate type of or accurate weld deposition. Here there is no slack, which because we don't have any flux type of components here, so there is no slack, and that too there will be no distortion, no spark, spatter or noise, and no spokes and fumes, right? So these are the advantages. When come to the disadvantage part, here lower filler metal deposition rate, means it is a very concentrated arc. So we have a lower metal deposition, as I already said with the previous video. I have set an example that it is mainly used for the root pass welding to fill only 1 mm of weld area. So it has a lower metal deposition, it has slower traverse speed. We have to have a hand-to-eye coordination, means that in one hand we are going to have a electrode, tungsten electrode, in the other hand we are going to use a filler metal which is fed manually, sometimes we fed manually. So we should have a hand-to-eye coordination, and we should have an arc rays are brighter than the other welding, which because it produces 6,000 degrees Celsius at a fraction of a second. It should be need additional care to protect skins with the proper clothing and welding lenses, and it is one of the costly process. Main applications that it is used in the aircraft industries, shipbuilding industries, boilers and pressure vessel industries, mainly on the root pass welding of pipes, as I already said about in the previous video and in this video also. It is mainly used in the nuclear industries, heat exchangers, and food processing. The small glimpse is that in filament metal not required for thin sheets, it can be added manually or automatically. It can be used as a rod or as in a wire. Joint isn't suited for all welding position. Deposition rate is very low and it is not suited for thick materials. Thank you.